Module 7, Section 5.1, Linear Inequalities in Two Variables. Objectives. Objective 1, graph linear inequalities in two variables. Objective 2, application of linear inequalities in two variables. Graphing linear inequalities in two variables. A line divides the plane into two regions called half planes. A vertical line divides it into left and right half planes. A non-vertical line divides it into upper half plane and lower half plane. In either case, the dividing line is called the boundary line of each half plane, as indicated in the figure. Graphs of linear inequalities. The graph of the linear inequality ax plus by less than c or ax plus by greater than c with b not equal to 0 is either the upper half plane or the lower half plane, determined by the line ax plus by equal to c. This is what we call the boundary line. If b equal to 0 and a is not equal to 0, the graph of ax less than c or ax greater than c is either the left half plane or the right half plane, determined by the line ax equal to c. So this is going to be a vertical line, x equal to c over a. So the two half planes will be the left half plane and the right half plane. Here we are going to look at some words that relate to inequality forms. So for example, if we state x is not greater than 85, we can write it symbolically as x less than or equal to 85. Not greater than 85 means less than or equal to. So similarly, x is not less than 85 means x is greater than or equal to 85. X is at most 85 means x is less than or equal to 85. X is at least 85 means greater than or equal to 85. And x is non-negative means x greater than or equal to 0. Y is non-negative means y greater than or equal to 0. So these two conditions together means that the points will be in the first quadrant. Here is a procedure for graphing linear inequalities. Step 1. First graph ax plus by equal to c as a dashed line if equality is not included in the original statement, or as a solid line if equality is included. Step 2. Choose a test point anywhere in the plane, not on the line, and substitute the coordinates into the inequality. We can usually take the origin as a test point if origin does not lie on the boundary line. Then we are asking the question whether the test point satisfies the original inequality. If it does, we will shade the side that contains the test point. If the test point does not satisfy the inequality, we need to shade the opposite half plane. So let's do an example. Graph the inequality 3x minus 5y greater than or equal to 15. When we replace the inequality symbol with equal sign, we will get the boundary line 3x minus 5y equal to 15. This is what we call the boundary line. We need to graph this boundary line 3x minus 5y equal to 15. And we are going to use a solid line here because the inequality is greater than or equal to. We will graph the boundary line by computing 2 points on it. We can conveniently choose the x and y intercepts. When x equal to 0, the y value is calculated as negative 3. We have 0 minus 5y equal to 15, so y will be negative 3. So if I substitute y equal to 0, I will get 3x equal to 15. That tells me that x will be 5. So we get 2 points. One point will be 0, negative 3, which is plotted up here. And the other point will be 5, 0, that is plotted up here. So we are going to join these 2 points using a solid line. Again, solid line is used because of the inequality being greater than or equal to. The next thing is to choose a test point. Because origin is not part of the line, I can choose the test point as the origin. Substituting the origin, that means x equal to 0, y equal to 0 in the inequality, we see that the inequality is not satisfied. On the left side we are going to get 0 and we are checking whether this is greater than or equal to 15. That will be false. So the origin is not in the half plane where the inequality is satisfied. So I need to shade the opposite half plane. So the shading will be up here. So this is a complete picture here. We have the boundary line, solid line. Shading is the side opposite to the origin because we tested at the origin and found out that it is not satisfied. So the half plane below this boundary line is the graph of the given inequality. Let's do another example here. 2x minus 5y less than 10. So step 1, we need to write the boundary line, which will be 2x minus 5y equal to 10. I may want to calculate 2 points. So if I select x equal to 0, negative 5y will be 10. So the y value is going to be equal to 10 over negative 5 or negative 2. So we get one of the points, 0, negative 2. And if I select y equal to 0, I will get 2x equal to 10. So that means x will be 5. So we get the second point, which will be 5, 0. So these are the x and y intercepts of the boundary line. Then what I'm going to do is I'm going to draw the boundary line. Notice that the inequality is strict, so my boundary line will be drawn as a dashed line. So the points will be 5, 0, which is up here, 0, negative 2, which will be on the y-axis, 0, negative 2. I need to use a dashed line here, so this will be the boundary line. Now the next step will be to see which of these two half planes I need to shade. So in order to do that, I'm going to take a test point. So test point will be origin, because origin is not on this line. So if I substitute x equal to 0, y equal to 0, and trying to see whether this inequality is satisfied. So 2 multiplied to 0 minus 5 multiplied to 0. Asking the question whether this is less than 10. Left side will be 0, the right side is 10, so 0 is less than 10. So this is satisfied. So the test point tells me that I need to shade the same side as the origin. So I will be shading this side. So the upper half plane is the solution set without the boundary line. Here is another example that we can look at. Graph the inequality 2x greater than 8. The inequality 2x greater than 8 is equivalent to x greater than 4 if we divide with 2. Remember that 2 is a positive number, so the inequality direction is the same. So it is the same as the inequality x greater than 4. So this will be the boundary line. So inequality is strict, so we need to use the dotted line or the dashed line for the boundary line. We can test at the origin. So substituting x equal to 0, 2 times 0, is it greater than 8? So the answer will be no. So we need to shade the side opposite to the origin. When we do that, we will get the boundary line x equal to 4. This is our y-axis, origin up here. So this extended will be the x-axis. So this is 1, 2, 3, 4. This is the boundary line drawn as a dotted line. And the origin is the test point. So it is not satisfied there. So we are shading the side opposite to the origin. If we want to graph the inequality y less than or equal to negative 2, we can use a same method. So the boundary line is y equal to negative 2, which will be a horizontal line. Inequality is less than or equal to, so we can use a solid line for the boundary line and shade one of the sides depending on where the equality is satisfied. So we have y-axis here, x-axis here, origin is up here. This is the line y equal to negative 2. And if I substitute x equal to 0, y equal to 0, that is testing at the origin, we see that 0, less than or equal to -2 is not satisfied. So therefore I cannot shade the side that contains the origin, so I will go to the other side. Shading here, solid line because of the inequality being of this kind. Example, graph the inequality 3x minus 5y less than 0 with the conditions x greater than or equal to 0 and y greater than or equal to 0. These two conditions means we only shade in the first quadrant. The boundary line is 3x minus 5y equal to 0. We need to calculate 2 points on this. So when x equal to 0, we will get y equal to 0. And we can also substitute x equal to say 5. Then 3 times 5 minus 5y equal to 0. That tells that 5y will be 15. So y will be equal to 3. So we have 2 points, the origin and the point 5, 3. So using these 2 points, I can draw the boundary line. So 0, 0 is up here, the origin. The point 5, 3 is something like up here. Now notice that the inequality is a strict inequality. So therefore I need to draw this line as a dotted line. So this dotted line is the boundary line. Let's label this as 3x minus 5y equal to 0. In order to shade the half plane, I need to test at one of the points. Notice that the origin is a point on this line, so I need to select another point. So I can conveniently select maybe this point 5, 0 on the x-axis. So testing at 5, 0. So that means I need to check whether the inequality is true. So it will be 3 times 5 minus 5 times 0. Is it less than 0? So that is the question. The left side is 15 and the right side is 0. So this inequality is not satisfied. So that means I need to shade the side that does not contain the point 5, 0. The half plane will be on this side of the line. But again notice that we are allowed to shade only in the first quadrant. So the solution set will be part of that half plane which is coming in the first quadrant. So this is the graph. Objective 2, application problem. A concert promoter wants to book a rock group for a stadium concert. A ticket for admission to the stadium playing field will cost $125 and a ticket for a seat in the stands will cost $175. The group wants to be guaranteed total ticket sales of at least $700,000. How many tickets of each type must be sold to satisfy the group's guarantee? Express the answer as a linear inequality and draw its graph. So we can model this problem using linear inequality. So we need to select 2 variables here. Let x be the number of tickets sold for the playing field and y is the number of tickets sold for seats in the stands. So these 2 values are what we are trying to calculate, subject to conditions. The total ticket sale must be at least $700,000. This is a kind of constraint on the selection of variables x and y. So how do we calculate the total sales? You multiply the number of tickets with the price for one ticket, which is 125. 125 times x plus 175 times y. So this is the total sales and that should be at least 700,000. So at least means greater than or equal to. So we get this inequality here. And notice that these numbers are multiples of 25. So if we divide by 25, we can get a much simpler equation. So if you divide both sides by 25, the inequality will be 5x plus 7y greater than or equal to 28,000. Though it is not explicitly mentioned, we can only have positive values for x and y. That is because we cannot sell negative number of tickets. So these two conditions goes with the problem. Now we can graph this inequality by first graphing the boundary line 5x plus 7y equal to 28,000 and shading one of the half planes. So this is the boundary line, and now if we test at the origin, the inequality is not satisfied, so we are going to shade above the line, the half plane above the line, but we cannot shade all the half plane because of the restriction on the variables x and y. We can only shade in the first quadrant. So we are using these arrows here to show that x has to be greater than or equal to 0, and these arrows here to show that y is greater than or equal to 0, and these two arrows means we are shading above the line, so we get this blue region up here.